In this video, I am going to walk through Code.org Unit 4, Lesson 10, Functions Practice. The objective is on the first level. Let's get into level 2. The instructions say these functions are not called in the correct order. Rearrange the functions to call the function calls to correctly tell the story. Okay, that's all it says in the do this instructions. Now I'm guessing that winter, summer, spring, autumn is supposed to be in the correct order of seasons. Let me look into the function code just to be clear. First comes spring when flowers bloom, summer's sun will follow soon. Autumn crackles red and gold, then hibernate for winter's cold. So we should really call spring first. I'm going to put this in blocks mode. It might be easier to move things around. Spring first, then summer, then autumn, and then winter, and run. And I think that the solution will come up in, I'm going to make it go a little faster. The solution comes up in the console log. So what this illustrates is that in a program that has functions declared, the calls are just single line commands that give the name of the function to be executed, and they all would come at the top. The declarations and definitions of what that function does are always kept towards the bottom of the program. Now, it does not matter in which order the functions are declared and defined. That will be parsed through on a first run through the program. When you first go to run a program, the compiler will parse through all of the code and kind of register what's there for, what it needs to do. And then it will actually start executing the executable statements that are not inside of functions, and it will do from top to bottom. So the first executable statement here in line 2 is that it's calling the function spring to do its job. So it will jump down here, do the job of the spring function, which is to just print out this line of code. Then it will jump back. And the order in which you put these function calls at the top does matter for how it will turn out when you run the program. But the order in which you declare them doesn't matter. All right, that's all we really needed to do for this level, and I'm going to click Finish and Continue. All right, on this level, it says this program will draw a building in the debug console. I guess it's going to look like this over here. Run the program and see how it works. Add code to the program to draw at least 3 more floors to the building. All right, let's check this out. The function calls at the top say roof, floor, and lobby. That's pretty reasonable, like it's very readable. You can see it's first going to draw the roof, then it's going to draw a floor, and then it's going to draw the lobby. So right now when we run it, I'm going to speed it up a little bit, just to save time as I go through this video. There we have the roof, the floor, and the lobby have been printed out. Okay, so it says add some code to draw at least 3 more floors to the building. So we don't actually have to create more floor functions. We just have to call the floor function 3 more times. And I'm going to use the text mode because it's pretty simple here. I'm just adding 3 more calls to the floor function. Reset, run, and in the console log, you should now see a taller building. That's the beauty of writing functions, is that they are reusable. When you define a function and what it's going to do, like floor is going to print out a little line of code that looks like windows and then another kind of brick, level. You can reuse that as many times as you like. And every time you call it, it will jump down here and execute that. Okay, you wouldn't want to put more roofs or more lobbies, but the floor, you would probably want to repeat. And the other beauty is that the functions have readable descriptive names. Roof is very clearly the top of the building. The lobby is the bottom of the building. We understand it because it's using good descriptive names for what it's doing. If it just said, bottom, middle, top, that might be kind of descriptive, but this even indicates you're talking about like a building, So I really like the way they've designed that. Okay, level 4. You need to spell function names the same way when you declare them and call them. Function names follow the same rules as variables. They must begin with a letter and cannot contain spaces. So run this program, read the error messages from misspelling the function name. All right, let's do that. Run the program. Error, syntax error, unexpected token, line 8, character 4. So, buy apple. This is not working. Actually, I noticed that warning, there's a warning on line 7 as well. Buy apple hasn't been declared. Line 8 has a missing semicolon. There's definitely something wrong here in these function calls. So when you look at the actual function itself, the true name of the function is lowercase buy, apple is uppercase, and there's no space in between. So the only function call that's working is this first one because that's exactly the name of the function. The other two have something wrong. This has a lowercase, this one has a space where it doesn't belong. Okay, debug the code to remove the errors. All right, I'm going to capitalize this A. I'm going to close the gap, no space. So it says now call buy apple. Let me run it just to make sure it's working. There we go. No more errors. What does buy apple do? I didn't even look at it yet. It says call buy apple enough times that you get a message in the console saying you have run out of money. Oh, so buying an apple will decrease the amount of dollars we have. And it says you'll be stuck in text mode until you fix the errors in the code. Okay. Yeah, so now that we fixed the errors, we could probably go back to blocks mode, but I like text mode anyway, so I'm going to stick with that. It's more compact and I have more control over what I can do. Yes, sometimes I will use these blocks and drag them in to help me, save time and remember all the parts, but I do like to keep it in text mode. So, buy apple. If dollars is greater than 0, I have apples. Okay, prints out. So we start with $5. I think we need to buy 5 apples because it looks like we're just losing $1 every time we buy an apple. So I'm going to put 5 calls to buy apple. That should get me down to 0. Let's try it. Now I have 5 apples. I need one more buy apple call in order to get the message that I run out of money. There we go. So you need 1, 2, 3, 4, 5, 6 calls to the buy apple function to use up all the $5 and then have it register, nope, I have no money left. So really only bought 5 apples. Okay, finished. Continue to level 5. This program has declared an update screen function, but it isn't called anywhere in the program. Read the code to understand how it works, in particular the update screen function. That's familiar. We were talking about that as a pattern last time, where the update screen is something we'd probably want to define in a lot of programs to update what's on the screen after a user takes an action. So let's see. First, we have a thumbs up of 5 and a mood that is not set to anything. If a person clicks on the down button, the thumbs up will get 1 subtracted from it. This is kind of like the likes that we looked at in a previous lesson. When the up button is clicked, it will increase the thumbs up by 1. But it's never updating the screen. So if we run it the way it is, and we look at we could watch the variable Down here, thumbs up is changing. If I click down arrow, it's changing. Thumbs up is changing if I click the up arrow, but it's not showing up on the screen. It's not updating. So it says we need to add code to update the screen by making calls to the update screen function. So that's all we have to do. And it even tells us in comments here where to add code to update the screen. So how do you call the update screen function? You call it by name. You just say update screen. Now, if you want to use the function menu, you can drag in not the one with a parameter, but because this one doesn't take any parameters, you still have to replace this with update screen, the name of the function. So there we go. And once I have that, I'm just going to copy, Control C, and paste it where I need it, like here on line 14 and here on line 24. That's where they're telling me to update the screen. Each time when we start the program, we want to update the screen. When the down button is clicked, we want to update the screen after this thumbs up is modified. And when we click the up button, we also want to update the screen. Reset, run. Now it starts off with the correct value for thumbs up. If we click on the down button, it updates correctly. If we click on the up button, it updates correctly. Now, it didn't change the mood. Till we get to 10. And it won't change it back to sad until we get to negative. Okay, so it's working. I'm going to finish and move on to the next level. Functions help you avoid repeating code in your program. If you're ever using the same pieces of code over and over, you should declare a function once at the bottom of your program and call it every time you need to use it. Okay, rewrite this program to use functions rather than repeated code. Read the program, identify blocks of code that are repeated. Declare a function for the block of code that is repeated at the bottom of your program. Replace the repeated blocks of code with calls to your functions instead of the repeated code. All right, so let's look at the code itself. Monday, morning, slept in late. Noon, lunch. Afternoon, scratched up furniture, slept in a sunny spot. Evening, hide. Okay, so Monday, Tuesday looks the same. Wednesday looks the same. Thursday looks the same. Friday looks the same. Basically, every day is the same in a cat's diary. So these 4 lines of code are repetitive. I'm going to Control C, copy, and go down to the bottom here, make some space, and I'm going to put them inside a function. Let me create the function header and then just paste, Control V, those lines of code into the function. Basically, you indent with 2 spaces to show the body of the function a little separate from other code. Remember, function starts with the function, and then you have to name the function. You could say day in a cat's life. That's what I'm going to call it. Because basically, every day is like this. So the name of my function is day in a cat's life. Now, each time those lines of code are repeated in the program, I'm going to replace them. I'm going to delete and replace them with day in a cat's life. And so I'm going to delete, replace with day in a cat's life. Delete the repetitive code, replace it with a call to a function. And don't forget, each function call is like a command, so it needs a semicolon at the end. Thursday is a day in a cat's life. Friday is a day in a cat's life. Replacing with a function call. Look how much more compact this program is now. I can fit it all on the screen. because I didn't have to repeat these 4 lines of code every time I want to show a printout of the day in Cat's life. All right, so I did that. I identified the repeated blocks of code. I brought them down to the bottom of the program, put them into a function, and then each place where they used to be in the function, I replaced those lines of code with just a call to the function. And here's the name of the function that I gave it, day in a cat's life. So now when I run it, it should still print out the same thing every day, but it's doing it by calling the function. If you watch when you run the program, it will jump down from here to here, print those out, then jump back, and then print out Tuesday, then jump into the function, and then jump back. You get the idea. Okay. I'm just going to click finish and go to the next level. This is a level to read and learn from. It's a reminder that when we create variables, we create them once at the top of the program, outside of functions or on event blocks. When we create variables, we should use the keyword var only once to declare the variable at the top of the program. You don't need to create that same variable again later using the var keyword. When you want to use the variable, you're just going to use the name that you gave it, not the var again. Okay, that could create errors that are sneaky because of the scope of variables. So you create your variables at the top of the program. This keeps your code organized. So really the order should be variables declared at the top, then executable statements and calls to functions, and then at the bottom, function definitions. This will keep your code organized and easier to read for you and others. Create your variables outside of any function or on event blocks. Here's why. A global variable is permanent. It can be used anywhere in your code. It can be used inside of functions and event handlers, but it can also be used outside of functions and event handlers. It can be seen by the entire program. So if you have var clicks get 0, this is a global variable because it's not declared inside of the body of any other structure in the program. You can still use it inside the body of another structure like an event handler or a function that you define, but it's declared, created globally. If you create a local variable inside the body, if you use the var command inside some other structure like an on event or a function, then that variable can only be seen in the scope of that function or structure, like an on event or a function, or we're going to later find that other structures, logical structures, can enclose things. That means that when you declare this and you set it equal to 1, it's just going to set the text of the counter to be 1 no matter what, and it will never change. Like, this will always result in setting a 1, okay? It's not like having it start off as 0 and then after you click the button, it changes it to a new value and prints out that new value. This will always be 1 because you're just creating a variable and setting it equal to 1 and printing it out to or setting the text of the counter to have that. Okay, so avoiding local variables is a good idea. Local variables will eventually be useful, but for now, they're most likely to just be confusing. The biggest issue you'll run into now with local variables is accidentally using var inside of an on event or a function. So if you do something like this, var count gets 0, and then you try to use count again, but you put var in front of it here, you're actually creating another variable, an additional variable inside the on event handler, and that's the one that will be updated with, and it actually might create an error, count plus 1, because which count is it going to use? Okay, this is confusing. Okay, it actually has two variables, one local, one global. They're both named count. Changing the value of one will have no impact on the other. This can cause unexpected behavior, and it may even cause errors. It can be tricky to debug. So the best way to avoid these issues is right now, make sure that you're not using var inside of an event or a function. If you run into a tricky debugging problem, check if you're accidentally creating a local variable. Okay, moving on. Level 8. This program should buy an apple every time the apple is clicked, but it doesn't seem to be working. Run the code to see how it does work. Okay. I'm letting it run through all the code and register what's there. Now I'm going to try something. It says click, so I'm going to try clicking on the apple. And that does execute by apple, but it says I had an undefined, now I have not NaN, and the wallet says NaN. That's not what we want, obviously. So it says debug the scope issue so that it runs correctly. What could be happening? Well, we have two variables that are global, dollars and apples. When we call the byApple function, that happens because the person clicked on the apple image. Here we have a problem. We are recreating the dollars and apples. So we're creating another variable called dollars and apples, which was never set to anything. The program will not know which dollars we're talking about here. Is it that one or this one? It's going to revert to the dollars that's closest or most local. So this is undefined. You can't do something undefined minus 1 because this is talking about this variable and subtracting 1 from itself when we haven't even set it to anything yet. So all we need to do is get rid of the var from here and here, because now these variables are not local new variables. They are referring back to these global variables, and those are the ones that have been initialized with proper values, and now it should work. So let's reset and run. The wallet has 5. When we get to clicking on the apple, it will call the byApple function, and now it says I had 0 apples, now I have 1, and the wallet says 4. Okay, that's it. We just had to delete the var from both lines 12, 11, and 12. Let's finish and go on to level 9. When to make a function. An important question for new programmers is, when should I decide to make a function? In general, the earlier that you realize you need a function, the better. This is a skill you will get better at with practice, and by the end of this course, you should aim to be in the during or before rows. Okay, so, I mean, if you never create functions at all, your code will be difficult to read and debug, and it will have lots of repetitiveness, and any place where you might make a mistake in that repetitive code, you'll have to go throughout the whole code, finding the other places where it's affected and make that same correction over and over again. Not a good idea. Aim to move on to at least the after step. You could write your entire program without functions, and then once you're done, look to see if you see anything repeated and move those into a function like we did in this exercise earlier. That way your code will end up being more easy to read and debug, and also more organized, okay? However, as you are writing code, if you notice that you are about to rewrite code you already wrote somewhere else in your program, you could, at that point, say, hey, this is getting repetitive. Let me declare a function and not have to do this again, later. So then declare a function, change the first instance of that repetitive code to a call to the function instead of the repetitive code. Okay. And this means you would kind of have a good understanding of your program and keep it organized as you develop it. Okay. The best option of when to create functions would probably be to have a plan where you think out how your program is supposed to run and whether any of it will be repetitive. And before you even write your program, you make a plan and identify places that you would have repetitive code, create your functions at the beginning. This type of programming reflects a strong understanding of how your program is going to be designed. You can almost see it in your head before you begin writing. And that said, it's okay if you sometimes realize that you need a function while you're writing your program and you work at the during stage. But these are definitely the more preferable times to make a function. Okay, continuing. To level 10. This program keeps track of tickets purchased for a performance. One of the buttons already has working code inside of it. The other two buttons will work similarly. Rather than write repeated code, practice creating an update screen function that you can call inside each on event. Run the program to see how it works. I've seen something like this before. Okay, the child ticket and the senior ticket is not doing anything. I bet if we were to watch the variables, maybe the variables are like dollars and tickets. Maybe those are changing even if we click, let's see, $25 tickets. I'm going to put a watcher on those variables. I'm going to run and click the child ticket. No, it's really not doing anything. Wait, let me reset and run. No, only the adult ticket is actually working. Okay. So read the code for the adult button carefully. Decide which lines of code belong in an update screen function. Declare an update screen function at the bottom. Add any code you think will need to run inside each button, and then add code to make the child and senior buttons work. They should increase the total number of tickets sold and the total money collected. Make sure you call your update screen function where it's necessary. Okay, let me get as much of this code showing as possible. And minimize this. Okay. The adult button, when you click it, adds 1 to the number of tickets sold. Basically, tickets is tickets sold. It adds adult price to dollars. That's the price total. If the tickets is greater than or equal to 20, it says sold out. Okay. It makes the sold out label hidden property false, which means it's no longer going to be hidden. The sold out label will come up. Then it sets the property of the dollars label text to say $sign and the number of dollars. It sets, I think this is all update screen, right? It even says it in the comments. So I'm going to take that code and I'm going to put it into an update screen function at the bottom. So go to your functions tab, grab the function definition block, which is like a little wraparound block. We're going to call this update screen. So let's change the name of the function from my function to update screen. And we're going to take these lines of code that are updating the screen from line 15 to 20. We're going to copy Control-C and paste with Control-V into the update screen function. And then we're actually going to delete them, 15 to 20, from the on event. And we're going to replace it with update screen function call. You give the name of the function, empty parentheses, semicolon. And I'm pretty sure that the other on event blocks just need very similar. Okay. I'm going to For a child button, update the tickets sold and put child price here. Child price is a variable. And then I'm going to update the screen. And for the senior button, I'm going to increase the tickets sold by 1 and change the dollars to dollars plus senior price. And then put the update screen. So same thing as here, 2324, we have to make a call to the update screen function. But we don't have to write out all this stuff every time we update the screen. We just make a call to the update screen function. Okay, that does save us several lines of code every time, because calling an update screen function only takes 1 line of code, but actually writing out all this stuff would take 1, 2, 3, 4, 5, 6 lines of code. So it makes our code more compact to just call the function each time we need that stuff to happen, rather than typing out all 6 lines of code or including it in those places. Makes it much more compact and readable, because we can see all we're doing is updating the screen. So let's reset and run. If you've done this properly, you should get no errors, but at this point you may have to stop and correct yourself. It's hard for me to show the entire solution unless I get rid of my console log. Yeah, I still can't really show everything at once, but you could stop the video at any point and look at what you need to. So running this program now, adult tickets adds 1, child tickets adds another, senior ticket adds more, different prices. At some point, we will probably be sold out. Sold out. Now, it doesn't actually stop a person from doing anything, but it shows the sold out. That's for another day, I guess. I think I'm finished here, and I'm going to leave the last question for you to answer on your own. So I hope this has been helpful. Have a good day.